My talk will be somewhat less technical than the previous ones. My background, I'm a engineering economist, so I've worked for many years trying to look at the costs of various energy projects in addition to their technical feasibility. In this talk, I'm kind of going to try to retain the conference objectives of some thought-provoking ideas. Boundless optimism here might be a little hard. Remember that I'm an economist, and there's a good reason they call economics the dismal science. And I'll also be, looking at things that, this future that one day might be in humanity's grasp. Most of what I'll talk about will deal more with maybe interplanetary missions than interstellar, since most of my background is nuclear. And I'm assuming that the technology for interstellar space travel does not yet exist. So many of the examples I use are going to be for the missions within the solar system. Okay, as an example of something that is more current, I'm going to use geoengineering as an example. Both interstellar spaceflight, interplanetary spaceflight, and geoengineering both require extensive national and international consensus and huge resources. Both will be hugely expensive. We're talking about terabucks or trillions of dollars. Both are going to be driven by long-term concerns regarding the survival of nations and even the human race. Now, consideration of geoengineering is already a reality. We can look at several different areas. One is the reduction of the effects of climate change, that is adaptation. It looks like the greenhouse gas levels increasing so fast, we're probably going to have a very difficult time getting it back down to the point we negate any effects. So we're going to have to look more at adaptation rather than stopping it. So there are some methods for reduction, and these also are going to require huge resources and huge changes in the Earth. Another one is the development of new water supply as a result of prolonged drought in a lot of areas, and this may itself be climate induced. Okay, what are some of the problems we're running into, or institutional problems, in doing this? For example, climate change. We're already encountering many political barriers. The stakeholders in all this are realizing that the solutions may impact their personal or national wealth. And another is that climate change may beneficially impact some nations and significantly damage others. For example, as we warm, some areas like Canada and Russia are actually going to have better conditions for agriculture. But the nations that are going to be most negatively impacted will be those mostly in the third world, closer to the equator, where the drought conditions are expected to increase and temperatures to rise significantly. Also, some of the lesser developed high carbon nations cannot afford the trillions of dollars that will be required to shift to new technology or to enact carbon capture and sequestration. An example is India. These countries are developing, they're burning carbon, they want to bring their people up to a higher standard of living. They can't afford the huge costs, for example, for carbon capture and sequestration, which is likely to add 30% or more to the cost of producing electricity from those sources. Now, the driving force for climate change related geoengineering is already reasonably clear. And there is scientific consensus in general that there is global warming, and that I think the real question and the problem is that people are starting to realize the huge changes in resources, financial resources, are needed to fix this. But by and large, there's scientific consensus. Now, one of the arguments against this, the huge cost, for example, a little chart down in the lower right shows that cap and trade will cost somewhere in the order of $1.9 trillion. And they compare this to other things like the New Deal, which costs $500 billion. These are in today's dollars, so inflation is in here. Hurricane Katrina's costs were about $150 billion. NASA, since its inception, has spent $851 billion. and the Vietnam War cost close to $700 billion. So the costs will be huge. There also is the problem, some other political barriers, and this is how to sell this to the public and politicians when a significant proportion of the world is still underdeveloped. Also with interplanetary and interstellar flight, the benefits to humanity are less clear. There will be fewer people that will benefit, so this makes it a particularly hard sell. Also, resource sharing between nations is very difficult to implement. We have had some successes, the International Space Station, in disarmament, but believe me, it is not easy to get the work started and to manage these kinds of projects. I have worked myself on some disarmament projects on plutonium disposition, and it just takes many years to get a project going because of the difference in cultures, the difference in business practices, and so forth, and we've run into this a lot with dealing with the Russians. And there are many who feel that human and financial resources should be spent on sustainable development and lower growth than on the technical fixes such as geoengineering or large-scale manned spaceflight. I got on the web and looked at some of these, and it's interesting that most of the people who are against this sort of thing are academics in the liberal arts, religious leaders, and leaders of undeveloped countries who take this view. I thought it was interesting to find out where the sources of these views came from. And many are skeptical even of advanced geoengineering, and also feel spaceflight is really in the science fiction category. And then there are also pessimists who say, well, why do we even want to go somewhere else and mess up our planet like we did ours? Now, some other issues are human health issues. I'm not going to go into any of these in detail because I think there's another speaker who will do this, but we have to deal with zero gravity, and there are engineering solutions possible for this, but we know that bone degradation, loss of muscular strength, and vision effects are there. We've seen this from previous missions. Radiation is a serious problem, but there are engineering solutions possible. Cosmic rays on a long mission can be fatal, and also when you shield these, you have to avoid getting secondary radiation effects from spallation. There are also psychological problems on a long mission. There are problems of food supply, waste product disposal, recycle. This idea of hibernation, like in the movie 2001, this right now is still science fiction. We're not there yet. There's an interesting book, by the way, Packing for Mars, that discovers some of these, and it's actually a rather entertaining book by Barry Roach. So. Okay, public risk perception could be a significant barrier to future spaceflight. I know this from being in the nuclear business. Now, nuclear thermal propulsion from low Earth orbit is really the only feasible method of sending large masses beyond the orbit of Mars. And most technology exists from the ABC's work in the late 1940s and 1970s. You get the high specific impulse, and actually after Apollo, NASA envisioned nuclear thermal propulsion for a Mars mission. At the bottom is shown the spaceship from Discovery from the 2001 movie. So at that time, this was looked at as the next big thing. There's two risks that cause concern to both NASA and the public. First, you need to launch a nuclear reactor into low Earth orbit using chemical rockets. So this would scare a lot of people. However, in reality, you're using uranium that has not yet been irradiated. It would actually be less radioactive than the plutonium-38 reactor or sources we put up there now. Also, the fuel for the NTP reactor is a form of highly enriched uranium, or HU, which is the same material used in some nuclear weapons. So you would now be handling this throughout the mission. And this was, NASA re-examined nuclear power for space applications in the early 2000s. And I worked somewhat at Oak Ridge on this JIMO mission. Eventually, the joint R&D program with DOE was dropped, and it was determined that the cost of a space reactor demonstration was very high. We can't do like we did back in the 1960s and 70s, where you go out in the desert, set up one of these rockets on a stand and run that. I mean, at that time they actually discharged the exhaust with small amounts of fission products onto the desert. Now you'd have to do this in some sort of building with cleanup. We determined that just a demonstration of this would probably be in the tens of billions of dollars. Also, handling this highly enriched uranium would have a huge impact on NASA operations, because now you get into a situation where you have to have guns, gates, and guards and high security. And also, space nuclear power is a pretty hard sell to the public. And I know NASA has experienced protests just over the launch of spacecraft using PU-238, such as the Cassini mission. However, I understand this last one we just launched. I didn't hear about any protests, but I'm sure if we launch a nuclear reactor, there will be some. Now, we look at just using nuclear power on Earth. A significant part of the developed world already opposes terrestrial nuclear power, which is actually easier, and would probably oppose space nuclear power. For example, most of Europe, Taiwan, and now Japan are going to move away from nuclear. A lot of this is because of the safety concerns from the 3 Mile Island, Chernobyl, and Fukushima accidents. And there's also concern about the proliferation of nuclear weapons. In fact, you have use HCU now as the reactor fuel with proliferation risk. So if we're going to have an international mission, nuclear mission, we're probably going to need to involve some international agencies such as the IAEA to regulate this. I'm going to move on a little bit to economics. Our research, development, and demonstration will be very expensive. The nuclear rocket program in the 50s and 70s spent through a few $billion, that is in today's dollars. We think new regulations and will make this R&D at least an order of magnitude higher. So we're talking now tens of billions to get to something we can launch. But in the long term, however, the nuclear propulsion might be the less expensive. We have a very high energy to mass ratio, about 10 to the 5th to 10 to the 6th, higher than chemical fuels. This is important since launch costs are high. And some of these outer system missions will be too far from the sun for photovoltaics. Now, the solar sail certainly may be a possibility. And as was mentioned earlier, nuclear power may not be sufficient for interstellar spaceflight. Now, the mission costs will be high. If we look at Apollo, they spent around $20 billion. That's in 10-year dollars. And the Mars mission would cost, with the base, is going to be in the hundreds of billions. And one nation is very unlikely to be able to bear all costs, especially if we continue to have worldwide economic problems. Launch costs right now, the latest I've seen to low Earth orbit are around $10,000 per kilogram. Geosynchronous Earth orbit are around 20,000 plus. And these are for chemical rockets and ground to space. Now, there are some advanced concepts that could reduce this cost significantly. The space elevator, this is the concept where you have in geosynchronous orbit the end of a tether, and you can actually send then material up the tether. This was one of Arthur Clarke's ideas. Seen one study that calculates $50 a gram. Another is a mass driver space catapult that uses electromagnetic fields to propel the spacecraft partway into orbit. And the study I looked at on the internet had a similar dollars per kg cost to the space elevator. Okay, what are some future occurrences that could boost the prospects for interstellar spaceflight? Well, it looked like there were going to be an eventual catastrophic collision of the Earth with an asteroid or comet. That certainly would get people more interested in this. And Stephen Hawking recently said we need this kind of insurance for human survival. How others, like Alan Guth, who's another physicist, says we might be better off with a giant underground bunker in the Antarctic. Also, if we have some sort of contact with extraterrestrial intelligence, that would certainly cause more interest in some sort of interstellar mission. Catastrophic climate change. One idea here is the space mirrors. There could be other scientific breakthroughs that would make this more technically feasible and less expensive, such as anti-gravity or new energy sources, antimatter, helium-3 fusion. Also, if there's some perceived military applications, you have to remember that a lot of the Apollo mission was done for diplomatic and military reasons. There are also some other, just more general, non-technical arguments for interplanetary interstellar spaceflight. That this is a human endeavor in the uniting all Earth's nations. That also that exploration of the unknown is a trait of intelligent beings, including us. And this SETI is this kind of mission. And Carl Sagan also discussed this in his books as an argument for SETI. One being this pale blue dot argument that that somehow we think there's other intelligence out there. Right now we're kind of alone, but it would be good to think that there's somebody else out there like us. Also, for some, the space exploration can be considered almost a religious quest. That is, a search for a higher power or higher intelligence. And this is looked at in science fiction a lot. This is more looking for a non-personal or a non-judgmental type of God that Spinoza talked about in some of his works. And that there might be, in other ideas, that there's a superior race of beings or overlords. There are also, in this interstellar spaceflight, some mythic and poetic possibilities for the arts. It can inspire a lot of things. Also, it can be a stimulus for education, especially science and math education. And science fiction has dealt with a lot of these. 2001 looked at this transcendent evolution idea. There's a mechanical for Leibowitz, kind of pessimistic, and talked about humans fleeing a nuclear holocaust. The Sparrow, considered a mission by Jesuit priests to Alpha Centauri after they heard this divine music signal. There's some other examples there. So in conclusion, it's going to be a hard sell in today's world, even in rich nations. Geoengineering will be easier to sell since the benefits are more apparent and in the near term. But the argument that man needs to explore has a lot of merits. It's a unifying concept, and it counters this nihilistic argument that man is just a speck in a harsh and infinite universe. And there are some international cooperation successes. We managed to get a protocol on the ozone layer and on the nuclear non-proliferation. But, however, things may have to get bad before we can move on to technological solutions. And that's it. This is about my email address, it's on there.
Time for questions. Anybody have any questions?
We got to jumpstart this somewhere. We need some entry points, some small demonstrations that there's a good payback. And part of this is writing down and speculation and talking about it. But the question keeps coming up, are there entry points for getting entry points to the process of building? Did you come across any of that?
Okay, these are entry points.
I'm sorry. Are there entry points
How
to
do you start
exploration
small before you go big?
and development? Can we not invest 20 trillion or 1 billion? Can we invest $500? Can we invest 20,000? 20,000 would buy us 1 kilogram in orbit. But can we show the payback from that is commensurate with a larger investment?
I feel a lot of our robotic missions actually are providing a pretty large payback. I mean, we've learned an awful lot about the universe in the last 50 years just from our space missions. I mean, personally, I feel it's wonderful. It's well worth what we spent. I'm not sure others all feel this way. I remember talking to my sister once about this, and she wondered, why are we spending all this money to send things to Mars? I had to argue with that this is exciting. This is new knowledge.
I don't know that this is necessarily the way I want to see it go, but even in Sagan's movie Contact, and Les, you talked about this somewhat in some of your books, the valuable resources that are like out in the asteroid belt, learning how to mine or finding, whatever the resource is, whether it's diamonds or gold or something that the major money structures of the world would find very interesting to get hold of. Maybe that's a way to push to say, we can get out there, you have a major reward if you find a cheap way to get out there and mine this type of stuff, and then reap the benefits off of what they have developed just so they can get their own gain.
Right, yeah, it's gonna be important when we bring down the cost of getting there and getting it back. Otherwise,
But
it'll be tough.
if you go with large companies who are after their own incentive, then hopefully, trickle down doesn't always work, but if they come up with the development, think that they'll get the greater reward, then we can reap what they develop.
Well, my co-authors and I, Ken and David, myself, will make the argument later today about that entry point and about basically hitching an economic mission to a technical object that has a national survival value so that the thing becomes self-funding. This is something you could do with solar sails if you put power production on it. So you'll be hearing more about that later today. The economics it's important. We've got to sell it to the business people.
Ken, I want to comment on the economics. This is just my opinion. The U.S. every year, the budget, we're all talking about how we have to reduce the budget or find other ways to fund it, is about $3.2 trillion. That's $3,200 billion. So even if a mission to Mars were $200 billion spread over 5 years, that's about $40 billion a year out of $3,200 billion. To me, that's not an unrealistic, unaffordable number. It's a matter of priorities. And so I guess as someone who's very sensitive to these things, because every time I hear NPR or anybody talk about a NASA mission, they always attach the price tag. But they don't always attach the price tag to the car accident on the freeway and how much did that 1 mile stretch of freeway cost. And so people don't have a perspective on this. So I guess I would disagree with you that it's an unaffordable amount. It's strictly a matter of priorities. It's really not that much money. It comes down to about a little over 1% per year of the U.S. federal budget to go to Mars. If that were somehow a priority, it's eminently fundable. It's just a matter of priority. It's not necessarily.
And you need the
inexpensive.
political will, also.
Yeah. So it's just a comment about not being unaffordable. It's just a matter of priority. Oh yeah, we have time. We've got a couple of minutes.
Along the lines of your remark just now, my collaborators and I are great advocates of electromagnetic propulsion and launch from the ground. A thing called Star Tram you can bring up on the web, and it can get the cost of launch down to $50 a kilogram within existing technology now. But the important thing is that if you do that, if you develop that technology, implicitly you've completely changed the proposition of moving people on the Earth. And if you look at the mortality in the United States from automobile wrecks, every day is equivalent to one major air crash. Every day of the year, one major catastrophe of an airplane crash. And the cost of that in terms of medical care is over $600 billion a year. And so if you can get this message across to people that changing the existing paradigm, building a safe transportation system with the required technologies also gets us access to space, then you have a completely different argument.
People don't understand risk. For example, a lot of risk, much greater than nuclear power.
Much.
I think we have one question over here, Ken, and then we tell you. Okay, go ahead. We do have time for two because we have a couple of minutes.
So, this was kind of a question I meant to ask Les, but being an economist, you probably have some insight into this. Different propulsion methods require different fuels, and the different fuels, I guess it's energy return on energy invested. Like antimatter, for instance, we manufacture it, would require a fair amount of energy, whereas the light sails require much less, just the manufacture of the sail. How big, this is one of the variables, how would you rate that as far as importance, or how important would that variable be in picking, if there were a number of technologies available to travel to nearby stars how would you rate the, I guess the amount of energy required to manufacture the fuel to go to a star? How important a variable?
I think a lot will depend on the quantities we need. I do know, for example, in looking at terrestrial power, that's a very important consideration. The lifetime energy use to produce electricity compared to what you actually get back. And there actually nuclear is very good in that respect compared to coal and things. But a lot of it will depend how much of the material you need. For example, for space nuclear, the amount of material we use is relatively small compared to what goes into nuclear power plants. So you might be willing to spend more up front to get this particular material that you absolutely have to have for space power.
Yeah, Carol had a question, I think it's the last one.
We're pretty much here because we've self-selected, we're interested in a topic, we support it. I think what we really need to be looking for in addition to technical solutions is how to convince Jedermann that it's in their self-interest to go do this. What is the self-selected, self-interest, survival, economics, whatever? What is it for me from, Joe Blow on an unemployment line somewhere, or somebody who's in a third world country? We have to identify a personal reason to want to support it. And how do we as a group do that so that then they start supporting the goals that we're talking about today?
It's a very good question. It's something we need to think about to help do this.
That's a good topic. Why don't we solve that over lunch? Not to take that lightly, Carol. I think if you look at the objectives of this workshop, one of the things you mentioned, we're a self-selected group. We are self-selected and selected by the people who organized to invite folks here. But I think it's because we got a diversity of interest, diversity of people we can reach. And I think that kind of collaboration among this group is something we need to talk about, is how we tie in with other efforts like Tab Zero, how we tie into Project Icarus, how we tie into media, all those kind of things. I agree with you, and I think that I'd like to see us get some kind of focused internet group where we can keep each other apprised of what we're doing, coordinate that, and try to do something like that.
Gotta push the blade out.
Yeah, we do, absolutely.